All right, today we're moving on to 5.7. Here in this section, when you're done, you should be able to classify triangles, whether by sides or by angle measurements. And also, you should be able to determine the angle measurements using the interior angle sum of a triangle theorem. As you know, triangles are polygons with exactly 3 sides. Right. And depending on the measurement of the sides, you can classify any particular triangle. So for example, if a triangle has 3 congruent sides, then you can classify it as an equilateral triangle. If you have a triangle with at least 2 congruent sides, then you can classify it as an isosceles triangle. And finally, another way to classify a triangle based off its sides is if a triangle has no congruent sides, then you're going to call it a scalene triangle. Again, all these classifications are based off of the measurements of the sides. So again, to classify a triangle based off its sides, you're going to say it's either equilateral, meaning all 3 sides are congruent, or isosceles, meaning at least 2 sides are congruent, and then scalene if there are no sides congruent. Another way of classifying triangles is by the measurements of their angles. If a triangle has 3 congruent angles, then you're going to classify it as an equiangular triangle. If you have a triangle with 3 acute angles, again, those are angles that measure less than 90 degrees, then you can say it's an acute triangle. A triangle with 1 right angle is classified as a right triangle. And then finally, a triangle with 1 obtuse angle. Again, an obtuse angle is an angle that measures more than 90 degrees. All right, so if you have a triangle with an obtuse angle, it's going to be classified as an obtuse triangle. All right, again, to summarize, ways of classifying triangles based off of their measurements of their angles. Equiangular, if all 3 angles are congruent. An acute triangle, if all 3 angles are acute, they're all less than 90 degrees. It will be a right triangle if it has 1 right angle. And then finally, if it has an angle that measures more than 90 degrees, then it's going to be called an obtuse triangle. Again, these are the 4 ways of classifying a triangle based off its angles. All right, one last term before we move on to some examples. When we talk about interior angles, the interior angles are the angles inside the triangle, and there's going to be 1 of these interior angles at each vertex. Again, the vertex are the corners of your triangle. All right, so what's going to be important for the next assessment is that you have to make sure you read the directions carefully, and you have to have the terminology appropriate for each problem. So example number 1 is asking you to classify each triangle by their sides. Okay, so again, you should be thinking about a very specific list to choose from when it comes to finding the answers for these 3. All right, so let me give you a moment, see if you can classify each of these triangles by their sides. All right, so here are the answers for those 3. Hopefully you did okay. Moving on to example 2, it says classify each triangle by its angles. So I'll give you a moment to work on those 3. Okay, so here are the answers for those 3. So now again, if you're not sure why or got some of these answers incorrect, you can look back at the definition for ways of classifying triangles by their sides and by their angles. All right, so for this next example, we're given the perimeter of that triangle is 20, and we're given expressions for the lengths of the segments, which are the sides. So determine if the triangle ABC is scalene, isosceles, or equilateral. All right, so again, we need to make sure that we are writing an appropriate equation for this particular problem. Because it's about perimeter, and that means it's about the sides. So let's see what you can do in terms of determining if this triangle is scalene, isosceles, or equilateral. Okay, so first we need to set up the plan. The perimeter of triangle ABC can be found by adding the measurements of all 3 sides, AB plus AC plus BC. Now that we have the plan, we can substitute in the values and the expressions that represent each of those parts of the problem. Again, this is our justification for this particular equation. The perimeter of the triangle is equal to the sum of all 3 sides. All right, so we've solved for x, and x is equal to 2. But we need to ultimately answer the question whether triangle ABC is scalene, isosceles, or equilateral. So we got to take that value of 2, plug it in for x for each of the sides. And when we do that, we find out that side AB has a measurement of 5, AC is 8, and BC is 7. And because all 3 sides are not congruent, that means that this triangle is scalene. All 3 sides are not congruent, making it a scalene triangle. All right, moving on to the next page of notes, dealing with the interior angle sum of a triangle. The sum of the interior angles of a triangle is equal to 180 degrees. So again, that means that the measurement of angle D plus the measurement of angle E plus the measurement angle F equals 180 degrees. Let's take a look at example number 4. It says find the measurement of angle F. Again, using that interior angle sum theorem, we're going to set it up as the measurement of angle D plus the measurement of angle E plus the measurement of angle F is equal to 180 degrees. And then we do the substitution for the given angles. And doing our algebra, we find that the measurement of angle F is equal to 32 degrees. All right, let's move on to example number 5. Here we're being asked to solve for x and for y. So we're going to first start with this triangle off to the right, because this triangle, we are given 2 out of the 3 angles. Angle C is 42, angle D is 90 degrees, and that last angle, which has x in it, that's the one that we need to solve for. So we set up our plan, substitute in our values, and solve for x. X is equal to 48 degrees. Now that we've solved for x, let's go ahead and solve for y in the other triangle. Well, you notice that in the triangle to the left, we only have the given angle E to be 100 degrees. Okay, in order to use the interior angle sum theorem for triangles, it's best that we'd have 2 out of the 3 angles in our triangle. But notice that that x angle that we solve for to be 48 degrees is a vertical angle pair with this angle that is blank right here. All right, so since vertical angles are congruent, we know that angle across from that is going to be 48 degrees. And with that, we have now 2 out of the 3 angles for that triangle off to the left. We can now solve for y. So we set up the plan. We make our substitutions and solve for y. Y is equal to 32 degrees. All right, so let's see what you can do here with example number 5. We need to find the value of x. All right, so again, because these expressions represent the angles, the interior angles of the triangle, we're going to use that interior angle sum theorem. It says the measurement of angle A plus the measurement of angle B plus the measurement of angle C is equal to 180 degrees. And then we do our substitution. And solve for x. X is equal to 33. All right, that's it for today. Go ahead and move on to the 5-7 homework.